We've seen so far case tools, we've seen DFDs, data dictionaries, and process specifications. But the next topic we're going to look at is a very important topic of software maintenance. Now, what happened in the 1970s is that software programs really proliferated. Okay, software programs proliferated, and you had a number of off-the-shelf programs, and because of that, people started using programs more often. They started being corrected, edited, etc. And slowly, people realized that it is not only enough to buy software programs and to use them, but they also have to be maintained, which means they have to be corrected, they have to be enhanced, they have to be adapted. So this software maintenance is as an activity was earlier not thought of at all. We just thought if you buy software program, it's going to work, but that does not work that way. Okay, so what exactly is software maintenance? Okay, software maintenance is the activities of maintaining software, of enhancing it, of adapting it, of correcting it. Okay, all this is software maintenance, and it uses up almost 60% of effort of any organization. 60% of the effort. Why do you think that is so? When we spend more than half our time maintaining the software. Well, the main reason for that is, first, the software, most of the software which is currently in use is almost 15 to 20 years old. Definitely 10 years old in most cases. At that time, the size of the programs was a very crucial factor, and the people wanted to make the size of the program as less as possible because this space was a major consideration. Now, because of that, they tried to compact the programs. They eliminated all comments, eliminated all the extra readability features, and made the programs as compact as possible. With that, of course, they sacrificed readability, and therefore they sacrificed the maintainability. That is one reason. Another reason is that old software was not developed using good programming techniques. Now, after doing a lot of research, or after a lot of work has been done on programming and how it should be done and what is the best way of programming, etc., we found out some techniques which can be used to make the program more efficient, more effective, and more readable, etc. All those things were not there 15, 20 years back. So probably the programming standards, programming techniques were not so good. And when these programs were carried on forward, all the bad qualities also got carried forward. So that's another reason why the maintenance takes up so much time. The last thing is that there is very little documentation. Again, this is something which is true even now. Most system analysts feel that documentation is a clerical job, which is below the dignity, and it's something which we should not be handling it. We are the programmers, we are the systems analysts. We should not be sitting and writing out things. That's a very wrong approach to take, because documentation is all important. Unless you clearly identify, define, you explain what you're going to do, the actual program becomes almost worthless. Okay. So documentation even now is a problem, and because of that you have very low maintainability, because unless you understand what the system is doing, you will never know what exactly you are supposed to maintain. In fact, when I was working with, I had given a test to one of our programmers. I asked him to write a program, and I took it back away from him, and after a week I gave it back to him and I said, now you tell me what this program is doing. He couldn't tell me, because there were no comments. And because there were no comments, you didn't know what the program was doing. So you yourself forget what you have written 2 weeks back. Okay, so whatever documentation is all important, which is why we take 60% of effort on maintenance. But does that mean that we spend 60% of our time in correcting problems? Are our programs so bad that we have to spend so much time on just error finding and error correction? Not really, because maintenance is not only error correction. So what is maintenance? Maintenance is incorporating the user and the business changes. It is incorporating, or it's correcting errors, of course. That's the important aspect of maintenance. It is enhancing the software in line with current technology. It is fine-tuning the system, and it is preventing future errors. All these activities put together, that is software maintenance. Now, correcting errors is a very important part, of course, and it normally takes up only 20%, but because it is such a critical part and it's such a high impact or high profile part of software maintenance, that is what most people think of when they think of software maintenance, error correction. Okay. Now, what are the different types of maintenance that you have? We are going to look at adaptive maintenance, corrective maintenance, perfective maintenance, and preventive maintenance. Let's look at each one of them. First is adaptive maintenance. What is adaptive maintenance? Adaptive maintenance deals with making changes in the system or adapting the system because of changes in the environment or technology or user needs. Now, as a user works on the system, as the system goes ahead, as you have changes in the business, changes in government policy, there will be some new things coming up, and the system has to be changed to take care of these new changes. That is what is adaptive maintenance. Okay. Adapting the system to changes in the environment. Okay. What is the procedure like for adaptive maintenance? Now, if your maintenance team is good and is working properly, then the procedure should be something like this. There will first be a request for service from the user department. Now, this request should come from the user department. The user should tell the maintenance team that we want this, and the reason why they want that. It should not be a frivolous thing. It should be something which is really critical as far as possible. Okay. All these service requests are taken by the maintenance team. They are screened. They are prioritized. Something which the service maintenance team feels that is absolutely critical is given top priority, and the others are prioritized accordingly. Then after that, the high priority service requests are then incorporated into the system, almost like the development of a mini system. So basically, when you want to add or when you want to change the system, it is like a fresh system development, with the difference being that you're not really adding anything, you are changing something. Okay, but in any case, it's almost like a mini system development. So you have to do that. You have to make sure that all the documentation is put correctly, all the proper flow charts, DFTs, all that is properly updated. So the documentation matches your system. This is the procedure which should be followed for adaptive maintenance. Another aspect of adaptive maintenance, apart from the processing of the service requests, is something called housekeeping tasks. Now, housekeeping tasks are time-bound activities which are critical but not so critical, in the sense if you don't do some of the housekeeping activities, system is not going to fail. But if you don't do them for a very long time, it still probably fail because of overload. Now, what are these housekeeping activities? First is backup and restoration. Now, we've talked about backup for a long time. A number of times in the past, we've said that the importance of backup cannot be denied. Taking a backup, documenting the backup properly, making sure that it is stored properly, all that is very essential. Purging and file reorganization, that's another housekeeping activity. Purging is something which is again very critical, very crucial, because once you remove something permanently from the system, it is gone. It is irreversible, you cannot get it back. So purging records or reorganizing of files has to be done very carefully under strict guidelines. Third thing is index or directory reorganization. As users continue to use the system, they might come up with new ideas, new requirements, which might need reorganization of the indices of the directories. That is something which is required. Then you have reset procedures. Now, reset procedures are when there are some historical totals. For example, you might have some year-end totals, or you might have some month-end totals, which need to be stored separately, and then those counters need to be initialized so that the next month or the next year's totals start piling up there. Those are reset procedures. Those have to be done. You have to update some parameters sometimes. For example, if the income tax department decides to vary the slabs, income tax slabs, or they decide to change the taxation rate, then obviously these parameters have to be updated, have to be corrected in the payroll program. So these are the housekeeping tasks which have to be done. They are mostly time bound, as I said. They have to be done. It's not that you cannot just ignore them, but they're not something which have to be done every single day. You have to have certain set procedures for doing them. This was adaptive maintenance. Then let's look at corrective maintenance. Now again, in corrective maintenance, that is the correction of errors. As in adaptive maintenance, there has to be a certain set procedure. Okay. The first thing, as in adaptive maintenance, you have the service request. Here you have the critical incident report, which means that the error has been detected, and this is it. This is the error, the explanation of the error. Then the maintenance team has to analyze the problem. They have to find out what exactly the problem is, try and identify the problem, then identify the solution to the problem. Okay. Then actually incorporate the solution, correct the software to make sure the solution is in place, and then most important, document all the updates. I've been emphasizing documentation also because I feel it's a very much neglected but a very important part of the software design process. So you have to document what you have updated, because there have been cases I know where the software says something and documentation says something totally different, in which case the maintenance team is the one who's going to bear the brunt of it, because they won't understand what the software is all about, what the documentation is all about. So in any case, the documentation has to be up to date. That is the last step which you have to do in the corrective maintenance procedure. Now, when you say that there are errors which come up, or when you say you have to correct these errors, what are the types of errors that can come up? Firstly, you might have the program logic errors. These program logic errors are probably because either the system analyst has not understood the system requirements properly, which means that you spend more time in trying to analyze or trying to talk to the user, or it could be that he has not taken into consideration all the possible options. For example, let's say in the employee records, in the employee details record, suppose the analyst has decided to give a 1-digit field for the employee's children. Now this would work fine if the employee has up to 9 children. What if an employee has 10 children? His program would fail. This is a case where the system analyst has not thought about all possibilities. Ideally, he should have given a 2-digit field. Obviously, nobody can have more than 99 children. But 2 digits are fine. Okay, that is what he should have done. The solution obviously is to spend more time on analysis, more time on the requirement study, something which we have been emphasizing from day one. The maximum time should be spent on talking to the users, trying to understand what they are saying, etc., etc. So more time is spent on requirement analysis. The next type of error which you have is the system errors. These are errors that are due to hardware or system software failures. For example, there may be a sudden power surge, or there could be an overflow of files, whatever. It could be that, it could be a paper jamming in the printer. Now, these could be a hardware or system software failures. They could also be due to the stretching of the system's capabilities. Now, the solution to that is obviously that you have to either get your hardware looked into, made correctly seen through, or you have to make sure that your system's boundaries, the stress conditions, are tested very carefully. Okay. The next type of error, the operations errors, which means errors which take place because the operators who operate the system don't know the job very well. Maybe they load the wrong stationery, maybe they take out the wrong report, things like that. The solution to that obviously is you have to give clear instructions. You have to make sure that the training is given very carefully to operations staff. You have to make sure that the operations staff are monitored to ensure that they are following those instructions carefully and properly. The last type of errors which you might have are the user errors. Errors which are made by users while working on the system, while doing data entry. The solution to this is again very, very involved and detailed training, detailed user manuals, extensive training. I mean, training is something which cannot be given less of. And in case you have user manuals, but you have users who are not willing to really look at manuals, errors which are made by users while entering data or while doing some sort of functioning on the system. Now, the solution to this obviously again is extensive training, user manuals, maybe online help screens for people who want to look at user manuals. That's the best way of handling these kind of errors. The next type of maintenance we are going to look at is perfective maintenance. Now, this deals not with correction of problems, but with improving the efficiency of a running program. Now, you might question why you want to touch a running program if it's running fine, but by improving even 5% of the code, a 20% improvement in the program's runtime can be realized. So, obviously, these things, if you want to improve the efficiency of the program, it is something which should be looked into. Now, what are the possible efficiency methods that can be used for increasing the efficiency of a program? Some of the sample efficiency methods which you can look at are maybe reading a block of records rather than a single record. The flip side to this, of course, is that when you read a block of records, you increase the program size. So, that increases. So, you have to draw a fine line. You have to see whether the program size is increasing too much. If that is so, then maybe you should not read a block of records. So, you have to see what exactly you are doing. You can also store the calculated values and reuse them instead of calculating them every time. This of course is more of common sense, and this is something which I am sure most people will be doing. You obviously will not be calculating each and every value again and again in a program. Ideally, you should be calculating them once and then storing them and using them again. You can improve the loops in a program. Now, this is something which was not thought about earlier at all. One of the bad programming techniques that we were talking about, one of them was the use of loops, indiscriminate use of loops, and not very efficient loops at that. You should make sure the loops are used efficiently. You should make sure that the innermost loop is working fine, is working correctly. This is how you can improve the efficiency of a program. Lastly, you can use default values. For example, if you have a data entry screen for the invoice, you can put in today's date by default, so you don't have to enter it every time. You just have to press enter once and the date automatically gets picked up. You are obviously saving on keystrokes, improving the efficiency of the program. So this is how you can improve the efficiency of programs, and that is what perfective maintenance is all about. Lastly, the preventive maintenance. Now, preventive maintenance of software engineering is required to modify computer programs so they can be easy to maintain, that is easy to correct, adapt or enhance. Basically, what this means is that this preventive maintenance is a sort of a fallback mechanism, a sort of something to get ready. Before the problem actually occurs, let's get ready and make sure that it is easy to solve the problem when it occurs. Problems are going to occur. There is no software which is error-free. Errors are there. The trick is to make sure that you are prepared enough so to spend as little time as possible in correcting the error. That is the idea. So, preventive maintenance is useful in that sense. Okay. We've talked about first three topics, case tools, DFD, data dictionary, process specifications, and software maintenance. Now we're going to look at software configuration management. Okay. What exactly is software configuration management? It is the art of identifying, organizing, and controlling modifications to the software being developed by a programming team. So, software configuration management, what it does is, it tells you the best method, or it tells you an organized method, gives an organized method of changing the software. Now, this is very important. Please listen to it carefully. What we are doing is that software is going to be changed. Change is something which is always there. The change can be structured, it can be done in an organized way, or it can be haphazard. SCM, the software configuration management, ensures that the change is done in a careful, structured and organized way. Software configuration management is obviously management of the software configuration. What is software configuration? Software configuration is all items comprising information produced as part of the software process are collectively known as software configuration. For example, you have software programs, you have user manuals, payroll data. They are all software configuration items because they are all products of the system. They are all information that is produced as part of the system. So, you have these are SCIs, software configuration items. Now, we have said that SCM tells you how to manage your change, tells you how to make sure that changes that you make in the software are organized, structured. One very important way of doing that is by using a baseline. Now, what is a baseline? Baseline is a specification or a product that has been formally reviewed and agreed upon, that thereafter serves as a basis for further redevelopment and that can be changed only through formal change control procedures. Let's go through it again. It is a specification or a product that has been formally reviewed. Let's take an example. Now, after doing the user requirement analysis, at the end of that stage, normally you have a requirement study document or a user requirement document, whatever the terminology may be. You have a manual which lists out this is what the user wants, this is what we understand it to be, etc., etc. That is a document. Now, that document is discussed, dissected, it is discussed between user and analyst, it is changed any number of times. Okay, before it is finally taken as yes, this is the guideline for the user requirements. This is what the user really wants the system to have. Once that is finalized, then that document becomes a baseline. Once that document becomes a baseline, any change that you need to make to the user requirements, to the document, after that, have to be done in a proper, controlled, formal way. What does this do? This helps in controlling ad hoc changes, helps in controlling haphazard changes. Before making that document into a baseline, you can do what you want. Change it as many number of times, change it as informally as possible, but after it becomes the baseline, okay, then it is fixed. Then you can't do anything with it. Okay? I mean, you can do anything with it, but you have to do it in a formal way, in a structured way. A procedure has to be followed. That is what is a baseline. Okay. And that is something which is very useful, because then you can manage the changes which are taking place in the software. Okay. The last topic which we are going to look at very briefly is object-oriented software technology. Now, what this topic does is, this topic really came about in the 1960s. It started in the 1960s, but it took almost 25 years for it to get really into the software industry. It became popular only in the early 1990s, and now many people take it as a alternative to the traditional method of this thing. Okay. Now, what exactly is object-oriented technology? Before that, what is an object? Let's take an example, a car. Now, a car is an object which belongs to a class of transportation. So, a car is an object which belongs to the class transportation. This has certain attributes like color, it has weight, it has cost, it has mileage. All these attributes belong to the class transportation. Okay, and these attributes are all inherited by the object. Okay. You have operations, or you have methods which are used to manipulate these attribute values. For example, if you want to paint the car red, then paint is the operation which is used to manipulate the attribute color from red, from the value red to the value say blue, in case you want to paint it from red to blue. Okay. So, operations are used to manipulate the attribute values. Then, how do you have objects? Objects are single units. How do objects communicate with each other? They communicate through messages. Okay. You have a message sent from object A to object B, which might be that please perform this operation, and this is the data which is to be used for that particular operation. B performs the operation, sends the information back to A. So, you have messages go forth, back and forth between objects for communication. Right. Now, why is OO technology so important? So, the main thing in object-oriented technology is that the operations are done, operations encapsulate the attributes of the data, which means that attributes of data are manipulated only through operations, and so data is hidden. When data is hidden, the side effects of the data of the changes are reduced. So, in normal traditional method, what happens is when there is a change, you are going to make the change, and while you are making that change, that particular point or that particular problem may be resolved, but you might end up changing some other thing somewhere else. Now, in this case, that is not done because the attributes can be manipulated only through operations, so they are hidden. Okay. So, you have side effects of changes are totally minimized. Next is the operations manipulate limited number of attributes. So, there is cohesion. There is cohesion between them, and secondly, objects are independent. They don't have any connection between different objects or different classes, so there is decoupling. All this, the cohesion, the decoupling, the encapsulation, all these imply that you have better quality of software, which is why OO technology is more important. We have little time, so we'll just look at very briefly the differences between the OO technology and the traditional approach. Three main differences. Encapsulation, as we said earlier, the attributes are manipulated only through operations, so the attributes are hidden by a wall of operations, they are encapsulated by the operations, and so the side effects of changes are minimized. You have inheritance, which means that an object automatically inherits all attributes of its class, so there is reuse. Then you have polymorphism, which is a slightly complicated concept. It's that the same thing, the same name of the operation can mean different things in different classes. And maybe we don't have time right now to explain it in more detail. Maybe let's keep it for next session. We can probably talk about it more in the next session, or you can go through the material which is there on the website. It's explained carefully there. So now we have this time for summarizing what we have done so far. We've looked at case tools. We've looked at the various types of case tools. We've looked at DFTs, data dictionaries, and mini specifications. We've looked at software maintenance. We've looked at software configuration management, and we've looked at very briefly object-oriented technologies. We are eager to hear from you, and we'll see you next week. Thank you.